Hello. So right now what I'm going to do is try to give you a crash course on Chapter 8 from Chris Odom's book, Physical Computing and Robotics, on the random number generator. Okay? And to do that, we're going to start off from the bare bones, but I'm going to go real quick and explain the foundation, and then we're going to jump into the module that Chris wrote to make it a lot easier for us to work with the random number and make it more reliable. But before we do that, we have to kind of understand the root of it and at least get a little sampling of it. So what I'm going to do, I've got a basic code right here. It's not set up to do anything except open a serial window, a serial port, and wait for the window. And as I did in the last one, I've got some basic code already written down below. I'm going to copy and paste something. And let's just go ahead and run this. You can see what it's going to do is it's going to generate a random number. I've set a limit here of 10. Okay, if I don't put anything else in this argument, it's going to just assume it's 0 to some value, and we're going to come back to that, 0 to 10, but it's not quite as clear as it seems. And then I'm going to have a delay of 1 second so we can actually see it. So let's load it up and see what we get. And coming up here after a few of these, I'm going to start pausing while it's loading so we don't have to wait, but this is important to watch. We are going to see the numbers. 1, 5, 2, 1, 1. Okay, let's watch it for a second, but let's remember 1, 5, 2, 1. And if you're really good, let's go with 1, 5, 2, 1, 1. But now we're scrolling down. We see a 9. Still the biggest number I've seen is a 9. It's a lot of dice rolls to not get another 9, but we still haven't got a single 10. Okay, well that turns out because it's between 0 and less than 10. So if I want it to go to actually 10, oddly enough, I have to make this an 11. Let's go ahead and load it again and see what we get. And again, I apologize. In the future, I won't make you wait. I'll pause while it's doing this. All right. All right, now 1, 3, 2, 5. Okay, well, that's good. It's different. It's different. That's excellent. Excellent. Well, let's load it up again. And so now we're going between 0 and 10. I should have waited until we got a 10. 1, 3, 2, 5. Okay, well, let's see if we get a 10 now. This could take a few moments. There we go. We got our 10. Let's go back again. Those numbers, 1, 3, 2, 5 are my first numbers. Let's take a look again. I'll make this the last because I think you're getting the point of this. And lo and behold, the first numbers, oh, that was deceptive, 1, 3, 2, 5. So you can see it's not really random. And if I do it again, we're still going to see the same pattern, 1, 3, 2, 5. We'll do it one last time just to drive this point home. 1, 3, 2, 5. Okay, wow, what perception I have. Now, it's generating random numbers from essentially an internal list. And what we want to do is we want to be able to move the position of which that list is addressed. Okay, and you can do that a couple different ways. One of the simplest ways is simply to put in a random seed. And let's choose a number. Let's say 30. Okay, and now let's load it up. And I bet you that we're not going to get a 1, 3, 2, 5 because we've we've rearranged things here. I'm sorry it's taking so long. Yay, look at that. 3, 5, 0. We fixed it, right? We've put a seed in here to rearrange it so it's no longer actually going to be the same set of numbers. Let's go ahead and do it. 3502. We're going to confirm. And oh, darn. 3502. Okay, so all we've done is shift our reference point to the left and to the right, and we still don't have truly random numbers. Okay, so somehow what we have to do is we have to make this number here random. We need to be able to randomly choose a different position to start our random number from. Okay, well, let's jump to another piece of code. Let me pause this and pull something else up real quick. Actually, I'm going to go ahead and show you where I get it from. So I'm going to go ahead and I'm going to give you a glimpse of the future if you're a George School student. And we're going to go ahead and open up examples. We're going to go to basics and we're going to look to analog read serial. And it's going to pull up this piece of code here. Okay? And I'm not going to explain how or why. All right, I'm just not at this moment. But I'm going to change this number. So we're going to get a display every half second. So I'm going to get a half a second. And now I'm going to jump down here. I'm going to show you what I've got. Here's the motherboard. And this is an infrared proximity sensor. Okay. And again, if you're a George School student, you'll be building one of these here very shortly. And these two lights here, okay, emit infrared light, and this measures it, okay? It measures the reflected light. So these are going to light up brightly. We'll probably be able to see it in the camera. And we're going to look for how much light comes bouncing back from an object. I'm going to be plugging this into this pin. Now, please don't think you're going to have to know how to do this. I'm just demonstrating why this works. Okay, not at this moment anyway. You don't have to do it. This is pin A0, this row right here, the last one that actually has a female socket next to it. Okay, so I'm going to plug this in right here with the yellow wire, the signal wire closest to the chip, and I'm going to come back to this code that we have, and you can see it refers to A0, and I'm going to load it up. Let me pause this because it's going to take a moment. Okay, so here I've got a sensor. I'm moving this piece of paper, and you can see that it's measuring the reflected light, and it's giving back a number. Okay, the further away I get, the bigger the number becomes. The closer I get, the smaller the number becomes. Okay. So the number, the value I get, is dependent upon the amount of reflected light. That's pretty cool. All right, you're going to be playing with this in the future. But what I really want to demonstrate is, what if I simply pull the sensor away? Now nothing's hooked up to the pin. It's a floating pin, okay? Nothing is connected. It's getting just random noise, all right? There's no way to get a feedback from it, and you can see that the numbers are generating randomly. It's amazing, okay? We can't choose the scale, but the numbers anywhere from the 80s to well over 200, averaging maybe in the 150, 224. There's really no predictive pattern. In fact, if I touch it, it'll probably change, okay? It probably depends a little bit on the humidity of the air, a number of factors, and it's always going to change. It's always going to drift, all right? It's a floating pin, okay? Now, we're going to take advantage of the fact that an unconnected pin like this reading the value of how many electrons are coming and going is going to be pretty random. And we're going to take advantage of that, and we're going to use this number as our seed. All right. So let me pause this and set it back up. Okay, so you remember that floating pin? If you recall from that example of the future, you can see that that used a function called analog read. Analog read what? Well, we're going to read pin 0. All right. So now we're going to use as our seed, our reference point on the list, a number which is going to constantly change. So you can see I've currently got it running and it's generating numbers randomly between 0 and 10. Let's do the quick reload test and let's see what the first 4 digits are. And I really should pause this, but yeah, I want to use the first 4. Okay, 5603. And we'll do it one more time. Eight, 9, 2, 7. Okay, so we've broken that non-random random number sequence. So now we truly have a random number. Let me pause this. Well, actually, let me show you one last thing before I pause this, and then we'll get into Chris's thing. So I've shown you how to go up to a range, okay? Remembering that you have to add 1 to your value, so it's going to be less than. So if I'm going from 0 to 10, I have to say 11. Let's say, for example, I actually want to go between two numbers. Let's go between 5 and 10. Okay, I could do it by simply putting a lower range and an upper range plus 1, and you can see that I'm going to pause it. Okay, now you can see that I'm generating numbers randomly that are in fact between, okay, 5 and 10, not 11, okay, 5 and 10. So let me pause this and set up the next whole section. Okay, we only got 3 minutes left before I hit my 15-minute maximum, so I'm going to go quick here. Now what you're going to do is you want to download Chris's random module, all right, and then put it inside your program. And again, like last time, you're going to see it's going to be under Files, and then from there you're going to go to Modules for GS students, and you're going to download the random module. Don't open it. Download it and know where you put it. Okay. Once you've done that, you're going to go to Sketch, and you're going to go to Add File, and you're going to find, mine went into Downloads. I'm not going to look for it because I've already done it, but you would find it in your list, and you would then add it, and here you see the random module. Okay, and there's a couple really cool things in here. Okay, there's only 3, so it's not going to be terribly hard to get to know. Seed Me is a quick and easy way and to put that random seed in your program. And I'm going to do that and then show you here. Random int is a great little function that generates a random integer. All right. And notice it's smart enough to add the +1 to it so you don't have to think about it. Random float is another awesome little function that generates a random floating point. So let me pause this, set up a couple things, and I'll see you guys in just a second. Okay, let's hope I can explain this in the next 80 seconds. That's all I got left. Let's look again real quickly here. We've got seed me, okay, which generates the random seed based upon the floating pin. We've got random int, which generates a random integer, accounting for the fact that it adds 1, right? So you can put in the numbers you're actually looking for. And we have a function here that generates a floating point, okay, a random floating point. So what I've done here is I have used all 3 of those. I put seed me in here, okay, so it gets a random seed. I've created an integer here based between -3 and 3, and then put those values in, and then have a concatenated string outputting. And I've done the exact same thing here with 2 decimal points, and I have a concatenated string because I'm using the serial print. I can only get 2 decimal points anyway, and you can see that it's outputting random numbers based upon this. So hopefully this was useful, and I'll see you again soon.